All right, so we have a frictionless roller coaster given an initial speed, v initial, right here, v initial, at a height h. Now look, h is measured from down here. This is the 0 point, right? This is h equals 0 down there, okay? Hey, one reason students have trouble with this problem is because it's all variables. Shh. Students don't like variables. Students much prefer having actual numbers. So here's how you do this. So the radius of curvature of the track at point A is r. So right here, this part of the track, it's like, you know, it's part of a circle. If you extend that circle, they're telling you that the radius of that circle is r. And the first thing they want us to find is the maximum value of v naught, the maximum value of this velocity here, so that the car does not leave the track at point A, right? Because what happens if the car is going too fast at point A? It's going to what? Catch some air. It'll leave the track. So, but we're solving for this velocity. What is the maximum velocity here so that the car stays on the track there? Now, what I would do if I were you is move this 0 point. I would move the 0 point and put the 0 point right there. Have that be the 0 point, right? So then what would the h be? What's the h going to be right here then? That's going to be h over 3, because that's 2/3 h. The whole height is h. So this is going to be h over 3. The problem really begins right here, though. What do we have to figure out at point A? We have to figure out, so let's say, so here's point A right there. Here's the car as it's going over that hill. What are the forces on the car up there? mg down, normal force up. If the car is at its maximum speed at point A, what's going to happen to normal force? It goes to 0. Center of the circle is always positive. For circular motion problems, make the center of the circle positive. So you sum the forces. mg points to the center, that's plus. This equals ma, that's a centripetal, right? Centripetal, what's the equation for centripetal acceleration? V squared over r, the m's cancel. V equals square root gr. That's the velocity at point A, square root gr. If the car goes faster than that at point A, then what happens? It leaves the track, okay? So that's our velocity at point A. Now, how do we find what this velocity is right here? How do we get what that velocity is? Well, it's going to be conservation of energy. Oops. Okay, so we're looking for this velocity. We know that the velocity at point A is square root gr. Move the 0 point to right here. That's the 0 point. So this starting height there is going to be h over 3. So what type of energy does the car start with up here? It starts with potential plus kinetic. Okay. What type of energy does the car end with right there? Only kinetic, because it's on the 0 point. If you would have kept the 0 point down here, if you kept the 0 point down there, then it would have ended with potential as well. Okay, so now let's plug in. This is mg h over 3 plus 1/2 mv initial squared equals 1/2 m. What's the velocity over here? Square root gr squared. So all the m's cancel. You can cancel all the m's out. And the only thing, let's see, we're looking for this. We're looking for v initial. So when you solve this for v initial, you're going to get square root g r minus 2/3 h. I left out some algebra. You know, like what I would do here is multiply through, take this equation right here, multiply everything by 2, okay, for starters. And then we'll simplify the algebra. It all simplifies out to that. That make sense? It's all variables. Okay, second question. determine the value of h prime. So now we're looking for this right here. Determine the value of h prime that's necessary if the roller coaster just makes it to point B. So guys, what does just make it mean? Just makes it mean it's going to go up, 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 and then what happens up there? It stops. The velocity goes to 0. All right, so we're solving for h prime. We have to have the 0 point down. Oops. We have to have, oh, darn it. Here, let's revert this. Come on. Well, it's smaller. I'll make it work. Okay, you got to have the 0 point down here because they're defining that for you. H prime is measured from down there. And they want us to use the value of V initial. So the value for V initial was square root G R minus 2/3 H. Aren't numbers better? Numbers are nicer, huh, when you're using that. So that's our starting velocity, 0 points down there. What type of energy do we start with here? Right there, we start with what? Potential plus kinetic at this point. So when the car goes down, up like this, what type of energy does it end with up here? Only potential, because the kinetic goes to 0. So when you plug in, this is going to be mgh plus 1/2 m. Okay, what's the velocity we're starting with? Square root g r minus 2/3 h squared, and then equals mgh prime. All the m's cancel, so now the rest is algebra. You got to solve this for h prime. When you solve that for h prime, it comes out as r over 2 plus 2/3 h. Okay?